Hi everybody, welcome to video number 45, creating a geomorphic map. In the last few videos, we've made a LiDAR visualization of Middlebury Gorge, and then we extracted a river profile from that LiDAR data set. In this video, I want to show you how to get started making your geomorphic map, and this will be the main goal of lab this week. Then we'll go out and ground truth these maps next week. So I don't expect you to be able to finish your geomorphic map during this video, but you can probably get started and follow along a bit and learn the basic approach to how you would make such a map. So the outline, I'm going to talk a little bit about the different types of geomorphic surfaces we're going to see in the Middlebury Gorge area. Then I'll show you how to create a shape file to start tracing these surfaces, and then how to go in and label each surface within your shape file. So most of the landforms in the Champlain Valley relate to the retreat of glacial ice. And one really common feature is just glacial till. This is the coarse angular rubble that's deposited beneath glaciers as they advance or retreat. And this glacial till will often fill in pre-existing valleys. So we're going to see that Middlebury Gorge was probably filled with glacial till as the Laurentide ice sheet peeled back. And this glacial till can often then smooth out topography and fill it with till. Now down in the Champlain Valley, we get another unique feature. This is called a came terrace. These are deposited as ice lobes slowly melt away, and you get some stagnant ice sitting down in the valley. And all the water that's running off the glacial ice sheets is running along the margin of the ice sheets between the ice and the valley wall. These rivers are carrying a lot of sediment, and they tend to fill in this little pocket between the ice and the valley wall. Then, when the ice finally melts, a lot of that sediment is still there, and that's called a came terrace. So we'll see a lot of came terraces flanking the edges of the Champlain Valley. Another feature we'll see a lot of are river terraces, and these can sometimes be called bedrock straths. As rivers cut down vertically towards a new base level, they will often erode a flat area that's the bottom of the active river channel. Then when they cut down again, they'll abandon the bottom of their river channel and they'll carve a new bench or a new strath. Then they'll cut down again, abandon that, and so on. And so as they cut down, it's leaving behind these strath terraces. And these are recording where the bottom of the riverbed was at different points in history. And it's going to allow us to reconstruct the incision history of the river. So we'll see a lot of strath terraces in Middlebury Gorge. Another feature we're going to see is a delta. So a delta is a body of sediments that's deposited where a river enters into a standing body of water. In this case, as the glacial ice retreated from the Champlain Valley, the ice lobe was blocking the northern Champlain Valley. And that actually dammed up a lake called Lake Vermont, which was many times larger than modern Lake Champlain. And its lake level was up at about 175 meters elevation. If you're familiar with the town of Bristol, that's about where the town of Bristol is today. And looking at this map, you can actually see the town of Bristol is built on the Bristol Delta, where the New Haven River delivered sediments into Lake Vermont. So deltas tend to be flat-topped, and they tend to fan outwards from the river mouth. So towards the bottom of the Middlebury River, you may well see deposits of the Middlebury Delta. However, note that these deposits cannot be higher than 175 meters, because that's the highest that Lake Vermont ever reached. And finally, you may see some shorelines. As Lake Vermont shrunk, this water level started to move away from the mountain flank, and we had a system or a series of receding shorelines that may have been deposited as this water shrank away. Those may be hard to see in the imagery though. Okay, so with that introduction, let's go to our ArcMap project and have a look at where we might look for some of these features. So here's the Middlebury River, here's the main Middlebury Gorge, And here's the main floor of the Champlain Valley. So one of the places to look for river terraces is going to be up here in these upper reaches of the river, and also down here, and then you're going to also see some river terraces out in here. Now if you're looking for delta deposits, keep in mind that those are going to be mostly out here near the mouth of the river. And of course, if you're looking for came terraces or outflow channels, those are going to be mostly along the flanks of the mountain. So for now, I'm just going to show you how to make a shapefile and get started tracing some shapes. So of course, to make a shapefile, let's go into Arc Catalog. In my output folder, I'm going to right-click, New Shapefile. And I'm going to make this a polygon, and I'm going to call it Geomorph Surfaces. And then, of course, it's very important to import the coordinate system from your LiDAR DEM. That way you'll make sure you're tracing over the right thing. We'll hit OK. So it's going to add that new shapefile. When I'm tracing surface features, I like to have the fill color be hollow, and I'll set this to red so I can see clearly what I'm doing. Okay, so why don't we start by tracing a river terrace. I found a nice one right here. The way I know it's a river terrace is it's very, very flat, and I can tell that it's kind of protruding or carved into the existing topography. And generally these things will kind of run parallel to the river as well, and they'll tend to be elongate in the direction of the river. So I'll go Editor, Start Editing, choose my Geomorph Surfaces, then Editor, Create Features, highlight Geomorph Surfaces, and Polygon. Now whenever you're tracing something, it's good practice to zoom in pretty much as close as you can. Now I'm going to make sure as I trace this to not go too far towards the edge, because I really want to make sure I'm only tracing and including points that are actually on the surface itself. I'm actually not going to go out here. That to me actually looks like another inset river terrace. If you see this shadow, it looks to me like there's a step down onto this lower little scrap of a river terrace. So I'm going to note that small little scrap of a river terrace. And river terraces don't have to be perfectly flat. I think I see some other ones over here that are also pretty nice. Notice this little flat area, then this one, and then this one, which seems to be disturbed by a river coming through it. So I'm going to go ahead and trace a couple of those. Again, being careful not to go off the edge onto the lower terrace, but also not to trace up onto the riser of the hill slope above. Just want to be tracing the flat spots, and it's better to be conservative than to incorporate stuff that's not actually on the terrace. Okay, so now we've traced 4 features that are river terraces. I'm going to also now look for something that I would call probably glacial fill or glacial till. And one of the clues to glacial till, it's going to be more expansive surfaces, okay? It's generally going to be plastered up against bedrock, and it's generally not necessarily going to be actually parallel to the river or necessarily even close to the river. So one of the places that jumps out to me is definitely glacial fill is right here. Notice this big flat area. You can tell by the way the river has cut into it that it's probably loose sediment. It's not bedrock. But it's also a little bit too flat to be bedrock. Okay, it's very flat and smooth. The other thing I can see from this grooving, that this is in fact bedrock over here. So I can see that this material is deposited right up against the bedrock surface, and it doesn't really seem to be associated with the river. So I'm going to go ahead and call that basically kind of a bench of glacial till. And I'm going to trace out the whole thing more or less Okay, so that's one example of glacial till. I'm also probably going to trace some out up here. Look at this really flat surface here. It is parallel to the river, so it could be a river terrace. On the other hand, I also like how it grades up and buttresses the slope, the bedrock slope, and I also like how I see it in a bunch of different places here. So I think I'm actually going to map that as probably glacial fill. And I'm going to draw a pretty big polygon around it. Notice I'm going to make sure to draw my polygon so I don't incorporate that little river that's working headward. But I will come all the way out onto the point. So although this looks kind of like a river terrace, because it's really the highest level, and because I see it laid into the whole valley here, I'm going to go ahead and call that the original glacial fill surface. Okay, so finally, let's go look quickly for some channels. I'm going to zoom in here in this area. Have a look at this channel right here. Notice that it basically comes from nowhere. It's a pretty large channel, but it has no upstream watershed. Same with this one right here, and these are parallel to each other, and they would also be parallel to the orientation of the ice sheet. So that's, to me, a big clue that these are what we would call glacial outwash channels. There was rivers flowing along the edge of the ice sheet, and water was flowing through these channels. When the ice melted, these channels were abandoned. So I am going to go ahead and trace these channels as basically glacial outflow channels. And it's always a little hard to tell where to start and stop a channel. And you don't have to be perfect. I tend to make them a little bit narrower as opposed to wider, just to denote that they're really a channel. And then I'll get this one too. Okay, finally, let's have a look for some delta surfaces. We know there was probably a delta coming out of the Middlebury River here, okay? And we know that the top of that delta is likely at about 175 meters. So I'm going to start looking around, and I'm going to start using my information tool. Make sure I'm probing the LiDAR data. That's 226 meters up here, so that's too high. If I come down here, that's 229, also too high. Down here, 182. That's a little on the high side, but could be within error. It's possible. Here's 178, 175. So this is getting down to the level where we would expect to see delta sediments. Also, it looks like these sediments may be another generation of sediments that are deposited as the river kind of swept out through here. And then look down here. This surface is at 167, 167. So what I'm thinking is the delta may have emerged from here, fanned out into this area, and this may actually be a scrap of delta that's preserved. So I'm going to go ahead and map that actually as a scrap of delta. And that's pretty preliminary. I definitely would want to go check that out in the field to make sure. But for now, I'm going to put it in there. And I'm also going to go, I think I'm going to map this feature here as a scrap of delta, because I think it's really at the right elevation. Okay, so now we got a couple deltas mapped there as well. And of course, don't forget all the river terraces that are down here. So now that we've mapped a few things and we know how to discriminate some of these features, let's go ahead and label them in ArcMap. So I'm going to stop editing. I'm going to save my edits, right-click on Geomorph Surfaces, open the attribute table, and I'm going to add a field. And I'm going to call it text. I'm only going to give myself 20 characters, and I'm just going to call it surface. Okay. Now I'll go back, start editing. Notice I had to stop editing in order to add that field. And I know the first 4 were terraces. It's important to spell things exactly identical if you want them to be treated as the same thing. I think I had the next 2 surfaces were glacial. Okay, so I labeled each of my surfaces with its own text name. I also went ahead and gave it a unique numerical ID. So 0 is for river terraces, 1 is for glacial surfaces, 2 is for outflow channels, 3 is for deltas. So I'll stop editing, I'll save my edits. Now, you've got the basis for a geomorphic map here. You're going to need to go along and identify many, many more surfaces, map them in carefully, and label them, and make sure they're properly ID'd in your shapefile. Final trick is that if you want to now export a subset of the surface types, you can of course you can sort things by right-clicking on any of the column headings. Okay, then you can select. Just right-click. Actually, just select those. Go over here, Data, Export Data. Choose Selected Features and File Name, and you're going to be able to output all your just any particular subset of geomorphic features that you might want to put into a new shapefile. And I'm going to do that now. I'm going to draw a few more terraces, then I'm going to output my terrace shapefile, my terraces into a new shapefile, so I can show you the next step where we're going to extract their elevations and their distances along the river channel. So thanks for listening. In summary, we've looked at 5 different surface types that could be mapped in this activity: river terraces or straths, glacial till or outwash surfaces, came terraces, shorelines, and paraglacial river channels. Join us for our next video, where I'll show you how to use the Locate Features Along Route tool to actually go ahead and extract the locations of these terraces. Thanks for listening.